If you feel confident with naming alcohols, then aldehydes, it is really similar process. So once again, I just want to take a look at table R. So you have your aldehydes, and you have an example name of what an aldehyde name should be. So every time you write the name of an aldehyde, it should follow the format of our example on table R. And when you have to draw the structure, whether it's a condensed or full blown, it should end in cho on the right hand side. So use your table R to your advantage. So here we go. Let's just start simple. So we have CH4, and this is our simple alkane methane. And we are going to do a substitution, right? So we're going to do that substitution reaction, and we're going to add an oxygen. So remember, oxygen has to form 2 bonds. And so when it comes in, this oxygen, it's actually going to substitute out 2 hydrogens. It's going to come in and kick those guys out. So what we end up having here is we have our carbon. It still has 2 of its original hydrogens still present, because every carbon needs 4 bonds. But then also bonded to it now is that double bonded oxygen. So when we take a look at our parent chain, we started off with 1 carbon in the parent chain. We still only have 1 carbon in the parent chain. So this is still meth, because it's 1 carbon. This carbon is not forming any other bonds with any other carbons, so we keep it simple as methane. But this structure as a whole, when you compare it to regular methane, it's a different structure. We have a double bonded oxygen to the carbon. So that means we need to adjust the name. So we drop the E, and this time we add an AL to the name. So the full name here would be methan al. I always overpronounce it. I say like big Al, only because methanal, methanol, they sound pretty similar. So if we do the condensed structural formula, you'll see this one written 2 different ways. So one structural formula is to highlight that cho, right? And then the other condensed formula you see once in a while, it's CH2O, but it's still a sequence. CHO is still that letter sequence that we have on aldehyde, that CHO. Let's just look at one more example. So right here, C2H6, we're going to start with a simple hydrocarbon whose parent chain is made up of 2 carbons, and each carbon gets its 4 bond fulfillment by adding 3 hydrogens to it. And so we know this as ethane. Well, we're going to put this through a substitution reaction, and we are going to replace hydrogens on this alkane with an oxygen. So this oxygen comes in, and remember, it needs to kick out 2 hydrogens because it has a 2 bond need. So both of these hydrogens are going to get kicked out when this oxygen comes in. So what we still have present from our original structure are the 2 carbons with their single bond. The first carbon still has its 3 hydrogens. The second carbon still has 1 hydrogen, but it also has a double bonded oxygen. we started off with a 2-carbon chain. We still have a 2-carbon chain, so it's eth. The ane, or eine is based on the bonds that exist between the carbons in the parent chain. So the only bond inside this parent chain is a single bond. So it's a single bond in that parent chain. So that's where the ane comes from. So the ane, or eine is what are the bonds that exist between the carbons in the parent chain. But because we have this double bonded oxygen on a terminal carbon, an ending carbon, we have to adjust the name. So we cross off the E and we replace it with Al. So the final name here would be eth and al. Ends in al means it's an aldehyde. If we translate this into the condensed formula, our carbon 1 has 3 hydrogens directly attached to it. Carbon 2, it has 1 hydrogen attached to it, followed by an oxygen. And here we see that letter sequence CHO that I pointed out on table R. So let's just take a look at one example here, okay, of drawing out an aldehyde. So take a look. First thing, when you're given the organic name, find the table P prefix. So I see bute. So that's my table P. Okay, so table P, bute means N equals 4. So I am going to draw my 4 carbons because that's how many carbons I have present. I got a little stray mark here. Now, when I take a look at the name, I see ane. So that tells me the bonds in the PC. And that means that they are all single. So we link all those carbons in the parent chains with single bonds. Now I notice that this ending is Al, which I'm learning to associate as the aldehyde. So that means I need to add a double bonded oxygen to a terminal carbon. So terminal means either the first carbon or the last carbon in the chain. So I'm just going to say traditionally, like 99% of the time, you're always going to see it on the most right-hand carbon. And so here it is. So now I've placed everything that's in the name into this structure. To finalize it is we need to add hydrogens to fulfill carbon's 4-bond need. So carbon 1 only has the 1 bond, so we add 3 hydrogens to it. Carbon 2 already has 2 bonds, so we only need to add 2 hydrogens to it. Carbon 3 has 2 bonds, so we only need to add 2 hydrogens to it. Carbon 4, it has 2 bonds that it forms with the oxygen, plus the 1 bond in the parent chain, so it has 3 bonds, so we need to add a hydrogen to it. If we draw the condensed formula, it would look like this. Carbon 1 with its 3 hydrogens, carbon 2 with its 2 hydrogens, carbon 3 has 2 hydrogens, and now carbon 4, it has a hydrogen directly attached to it, so we put the hydrogen. Then the other thing directly attached to it is the oxygen. And right here, we can see in that condensed formula, CHO.